Hey, hello, and welcome to today's GFG problem of the day, gold mine problem. Let's see what the problem has to say. Given a gold mine called M of n into m dimensions, each field in this mine contains a positive integer, which is the amount of gold in tons. Initially, the miner can start from any row in the first column from a given cell. The miner can move to the cell diagonally up towards the right, to the cell diagonally down towards the right. Find out maximum amount of gold which he can collect until he can no longer move. So let's see through an example, right? So this is the gold mine given, right? This is the gold mine given. And what the problem is saying is that we have to collect the maximum gold, right? And the miner can start from any element in the first column. From any element in the first column, he can start with any row, basically any row basically in the first column. Okay. And then what he has to do is he has to collect. Now he can, let's say if the miner starts from here, right? So he can either go to the diagonally up, right up, only to the right, and diagonally right down, right? He can move only in these three steps. Okay. And finally he can reach, right? He has to collect maximum gold until he can no longer move further, right? So let's see what so here, if you see the example, right, what path he has chosen in this one, right? 1 0 1 0 is what? 1 0 is this, right? First row, zeroth column, right? And then he is moving where? 2 1 2 1 2 1, which is second row. 2 1 in the sense, if we consider zero based indexing, right? So 2 1 is this, right? So he is going here, right? And then after this, post this is going 2 2 2 2 is nothing but this one, right? So he's going this. So what? So maximum gold he can collect is 2 plus 6 plus 4, right? Which is 12. So each this is gold unit. Each element is gold unit. He can collect maximum 12, right? So so also, yeah. So what we can do is, how we can solve this problem, right? So what we can do is, and also if you observe, right, if you observe this pattern, what they are doing, what the miner, what it is suggesting is, see, first he took the maximum element in the first column, right? Maximum element in the first column. And then once he chose this, then what we are seeing is, we are choosing this. So again, which is maximum element out of these three, right? We are going this way only. And again, for this element, the option was this and this one. So anyone we can choose, right? So we chose this, right? We chose this. So we are choosing, in each step we are choosing the maximum element only, right? So what we can do, rather than starting from here, right? Let's see how we can do. So what we'll do is, we'll start from this column, the second last column, this column, this particular column, right? And what we'll do in this way, uh, let's see, through the code as well. Oh, this will be little, yes. Okay. So we'll start with this particular second last column we'll start with, okay? And then what we'll do is, we will take another matrix, the copy of the matrix, right? Will not modify the original matrix, as the problem is suggesting we have to take extra space anyways. Okay. So let's say this is a problem, right? So what we'll do is, we will check, right, which is the maximum element, right? And diagonally right down, right? Right down. Okay. So here the maximum element, we can take anything, right? Here it was, sorry, 133, 133, right? 214064. Yeah. So maximum element is this, right? So what we'll do, we will increment this one. 3 plus 4 will take, 3 plus 4 will, it will be 7, 7. Okay. Let's yeah. So 3 4 4, right? So here the element is 3 plus this element you have chosen, right? So we'll put it 7 over here. Okay. And then we'll come to this element, this particular element. What is the maximum element out of this 3, right? We have 3 options, right? Diagonal right up, right, and diagonal right down. So 4 is a maximum. So we'll 1 plus 4 will do 5. The element plus the maximum element, right? And then for this particular, which are the two options? These are the two options. These are the two options, right? So 6 plus 4 will give 10. right? Similarly, again for this one, for this particular we have two options, right? One is this and one is this, right? So we choose a maximum, right? 1 plus 7, it will be 8. Then 2 we have three options, right? So we'll take the maximum one. 2 plus 2 plus 10, it will give us 12. For this particular element we have two options, 5 and 10, right? So we'll give 10, right? And then what we'll do, we'll iterate through the first column, right? We'll iterate through the first column and we'll choose the maximum one, right? So if you see the code, here is a code, right? We are starting with the second last column, right? The second last column. And then what we are doing, we are calculating the right, we are taking the right, fetching the right, right up, right down, right? So right m copy row of call plus 1, that is, if let's say 3214 064, right? If this is the element 1, so right, what is right? This one, this one, right, call plus 1. Then if row is 0, if row is 0, then we are just selecting for right up, we are just selecting 0. else 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 row minus 1, call plus 1, right? Row minus 1, if this is the element, row minus 1, call plus 1, right up, right up. And right down is, if it is not n minus 1, if it is this n minus 1, we cannot go down, right down we cannot go down, right? So we'll simply use 0, we'll simply use 0, yeah, that is right down will have 0 here, right? Else, right, we can simply row plus 1 and call plus 1, right? So we'll choose this one, right? So write down, and then what we'll simply do, m copy whatever is the element, right? If it is 6, this 6 element, whatever is the element, and we'll have the maximum out of these three, right? Maximum out of these three, and simply will add. So simply we are building this matrix through this m copy, and then simply what we are doing, we are iterating through the first column only, and the entire row, and whatever is the max, we are returning max. So this is the code, right? So the Java and C++ will almost be same. Only difference will be in creation of this matrix, 2D matrix, right? So let's, here is a problem. And again, they are saying additional space, right? We could have used the original array, the original matrix, but since they are saying that, let's not modify the original one. And they are saying extra space you have to take. So we've taken extra space over here, created the copy, and simply, as I said, right, we are calculating right up, right down, and simply whatever is the maximum we are taking, right? And then iterating through the first column, and whatever is the maximum we get, we are returning. Okay, let's submit the code. So yes, it is accepted. Thanks for watching. Please like the video and subscribe to my channel. Thank you so much.